Okay, in this question we are given a square courtyard of size B. Let me start drawing this. Bounded by a perimeter wall and a square building of side A, essentially within the placed centrally within the courtyard. So something like this. Guards can stand at either the middle of a perimeter or in the corner. So guards can be either in the middle or in the corner. If the guards wish to see as great a length of the perimeter wall as possible, determine which of these positions is preferable. You should consider separately the cases B is less than A cubed or 3A, and B is greater than 3A. So whenever I see a question like this, where it tells me to consider two cases separately, I think an alarm bell should go off in your head to say something changes when B or A goes over that threshold. And then I would ask myself, well, what might this mean in terms of this diagram? So if I were to draw lines from this corner like this, if I were to change the size of A, for example, so let me change, wrong one, let's change the size of A to be much smaller, because these conditions affect the relative size of A to B. Oops. Where's my square gone? There it is. So if this is much smaller, we're still looking at the same section of wall. Okay, so nothing significant seems to change. Obviously the scale changes, the size of A changes, but nothing. But that's just the angle that it's at, right? There's nothing significant happening. But when we look at the view from here, we see that, well, here we have a cone of vision like this, right? Let me just choose a different colour, which is red. If we have a red larger square in the middle, sorry, these are supposed to represent squares. Oops. And straight lines. Your field of vision is now well, it's significantly different because you don't go over this lip here. Okay? So seeing this question, it makes me immediately think that this condition is met when let me draw another square here. When from the middle to the corner, and you have some square in the middle like this, when this condition is met. So let's go ahead and show that this is the case. So we have a B over 2 here and a B here. And let me draw these lines here. So if I drop this down like that, and bring this across like this, we have A over 2 and we have B minus A all over 2. That's just the length of this and the length of this. Now, these two triangles are going to be similar because they have the same angles. So we know that the ratio of them is going to be the same. So that means that B over 2 must be equal to B minus A all over 2 over A over 2. So if we cancel the 2's from that one, cancel the B's from that one, so that becomes 2A equals B minus A, so 3A equals B. So at this point, when 3A equals B, our cone of vision goes directly into the corner. So the intuition there was correct. Okay, so we can now think about these two situations separately. So I'll do one. Condition 1 is 3A is bigger than B, and condition 2 is 3A is less than B. So let's look at condition 1 first. I'll have to draw it again. So we've got 3A A is bigger than B. So A is bigger means it's one of these ones. And well, we may as well start from the middle there. So if we look at, actually, let me draw another 2 lines. I'll draw these lines and drop these ones in again. We have this, what's this going to be? This is B over 2, which is all of that. This is B minus A over 2. This here is A over 2. What else have we got? We've got some unknown X here. Okay, so let's use the same trick that we just did before, where we see that different colour. This triangle here is similar to this triangle here. So let's draw these. This one here, this one here. And we've got A over 2, B minus A over 2, B minus A over 2, and X. So let's use the ratios again. So B minus A over 2 all over A over 2 equals X over B minus A over 2. Let's cancel these. B minus A all over 2A equals X. So the total that this guard can see, so middle is equal to 2 lots of B over 2 plus B minus A all over 2 plus B minus A all squared over 2A. Cancel those 2's on the bottom. 2B minus A plus B minus A squared over A. That's what the guard can see from the middle. Okay, let's do the same from the edge, from the corner, sorry. So this was big, and not that it matters from the corner actually. And we've got this. And I'll draw these ones in again. So what do I need to know this time? Say this one here is B minus A over 2, which is equal to B plus A all over 2, B minus A all over 2, and X. Yeah, X, because we don't know what this one is. Let's not call it X, because we just had an X. Let's call this Y. Okay, so let's figure out Y. We can use the same trick again. So we've got B plus A all over 2 over... Sorry, I don't want to do that way, do I? I want to do it the other way around. So I want to do this length here, which is B minus A over 2, divided by this length along the bottom. So that's B plus A over 2. And that must be equal, because of similarity, that must be equal to Y over B minus A over 2. I'm assuming here that everyone remembers similarity from their GCSEs. Effectively, it's the ratios of the sides of two similar triangles are the same. So that's what we've been doing. Cancel these. So Y is equal to B minus A all squared over B plus A, or 2B plus A. So the total corner is equal to 2 lots of the whole side, which is B, B minus A over 2, and then this thing here, so that's B minus A all squared over 2B plus A. 2B plus B minus A plus B minus A squared over 2A plus B. 3B minus A plus B minus A squared over A plus B. Voila. Okay. So we've got the total from the middle and the total from the corner. So now let's look at the total. In fact, no, let's look at the difference between them. So suppose we're doing, we'll do the corner minus the middle. Right, so we want to know which is more. So if the corner's more, then this that we're working out now will be positive. And if the middle is more, it'll be negative. So corner first, we've got 3b minus a plus b minus a squared over a plus b minus that was the corner, so this is the middle. So 2b minus a, 2b minus a, and then it was plus b minus a all squared over a plus b minus a all squared over a. Okay, see what cancels. They cancel. We've got b plus b minus a all squared over a plus b. Minus b minus a all squared over a. Let's multiply. So if we do b, a, b plus a, so I'm basically making this into a single fraction. B minus a squared a minus b minus a squared a plus b all over a plus b. Okay, so we've got b squared a plus a squared b. Actually, this cancels with this one, because they're both a and then b minus a all squared. So it's minus b lots of b squared minus 2ab plus a squared over a plus b. Right, let's see what we've got here. Let's take a b out of everything. So we've got ba plus a squared minus b squared plus 2ab minus a squared all over a plus b. The a squareds are going to cancel. So we end up with, we can take out another b, so we've got b squared, and then we've got 3a plus minus b all over a plus b. And then we said that, what did we say right at the beginning? We said that 3a is greater than b. 3a is greater than b. 3a is greater than b, so this is greater than 0. So therefore, corner is better than the middle. So corner is better than middle. For case 1. Okay, good. Let's look at case 2. I'll go and do it over here to the right. Just choose a different colour. Red for case 2. So case 2 was when we had a square, an inner square. Sorry, it's probably too big. Inner square. And we're looking from the middle to the edge. Yeah. Okay, so we want to figure out, what do we need to figure out? We need to know this distance here. X. We're starting here. So what do we know? Well, if I drop another line down, like this, I've got a over 2. B minus a over 2 here. B minus a over 2 minus x here for this bit. And what's this bit down here? It's b minus b over, sorry, b minus a over 2. B plus a all over 2. So this one here is b plus a all over 2. Right. So we need to find out x again, so we can do the same trick, and we just have to be careful digging out x. So we've got this over this, so the two fractions b minus a all over 2 must equal this one divided by this one. B minus a over 2 minus x over b plus a over 2. Okay, 2's cancel from the left hand one, and I can times top and bottom by 2 here. And then I can do multiply by a plus b. B minus a equals b minus a minus 2x. So 2x equals b minus a minus a b plus a over b minus a. And let's make that a single fraction. So we've got b minus a all squared minus a that. B squared minus 2ab plus a squared minus ab minus a squared. So and that's over b minus a. A squareds cancel. Equals b. And then what have we got left? B minus 3a over b minus a. Sorry, and then that's 2x. So if I just make x equal to that over 2. Okay, so the middle total is equal to, we've got b over 2, sorry, 2 lots of b over 2 plus b plus, so b over 2 is this bit, b is the entire side, and then the x is the bit at the top. So b minus 3a over 2b minus a. So multiply that out, it gives b plus 2b plus equals 3b plus b minus a. Cool. The corner should be the same as the corner from before, because nothing has changed in the corner. So let's use the one from the corner. So it was 3b minus a. So corner 3b minus a plus b minus a all squared over a plus b plus b minus a all squared over a plus b. Okie doke. And then we'll do the same thing again. Now I'm going to assume that the answer is going to be middle is better in this case. So I'm going to do middle versus minus corner. Obviously, if this is negative, I've got it the wrong way around, but I'm going to guess that's going to be the trick. I don't know though. So let's do middle minus corner. So middle was 3b plus b minus 3a over b minus a minus the corner. So minus 3b minus a plus b minus a all squared over b plus a. Okay, 3b's cancel. We've got b minus 3a over b minus minus a plus a minus b minus a all squared over b plus a. Okie doke. Oh, am I going to have to multiply everything out? I think I am. Okay, so b squared minus 3ab. Actually, no, that's... Yeah, okay, that times by b plus a. Plus a, lots of... well, it's going to be b minus a, b plus a, so it's going to be b squared minus a squared, using difference of two squares. And this is going to be minus b minus a cubed, actually, all over b minus a, b plus a. So we can have b cubed minus 3ab squared plus ab squared minus 3a squared b plus ab squared minus a cubed minus b cubed plus 3ab squared minus 3a squared b plus a cubed all over b minus a, b plus a. I'm going to zoom out a little bit here. Oh, zoom out a bit too far. There we go. There, that's about right. That line. Right, so things should cancel here, hopefully. They cancel. They cancel. Good. Okay. What have we got? AB squareds. AB squareds. We've got minus 3 plus 1 plus 1 plus 3 plus a squared b's, of which we have negative 3, negative 3. Yep, that's right. All over b minus a, b plus a. Right. Cancel. So we have a, b, 2b minus 6a. In fact, let me just take a 2 out of both of those. So if I put 2 here, I've got 1 of those and 3 of those. All over b minus a, b plus a. Now, ab bigger than 0. B minus a is bigger than 0 because b is bigger than a. B plus a is bigger than 0. So everything here is positive. What about b minus 3a? Let's find our original condition. B minus 3a. We're doing condition 2. So b is bigger than 3a. So from condition 2, b is bigger than 3a. So that means that the middle is better than the, so middle is therefore better than the corner, which is what we thought it probably would be. Good, okay. So hopefully all that makes sense. Let me just zoom back out again and get like an overview of this. So we started thinking about this condition, and I warned you that the two cases, b less than 3a, b greater than 3a, is probably going to mean something, some kind of threshold. And we figured out that the threshold was going from the middle of an edge to a corner. Then we figured out, well, then we sliced the world into two conditions, which we call 1 and 2. 1 was 3a is greater than b, 2 was 3a less than b. then we just took the two things completely separately. So from then on, it's essentially just two questions. One was in green, one was in red. This is the sort of way that you need to think about doing these questions. Okay, getting the high level structure right, so that when you're solving the algebra, you're not worried about how what you're doing relates to the question as a whole. So splitting it into two conditions and just looking at those two things separately. It's a skill that you should really be able to do from your A level, but probably you might not be used to each separate part being so big. If you split it into two conditions, it might be like one or two lines after that, but this is like two conditions and then boom, loads of algebra. Good. Anyway, well done.